Hello and welcome back. It's great to have you on this channel where we dive into cutting-edge developments in the world of blockchain and cryptocurrency. In today's episode, we're exploring one of the most revolutionary projects in the crypto space, Ethereum. Whether you're new to Ethereum or a seasoned blockchain enthusiast, you're in for a treat as we break down what makes this decentralized platform so powerful and unique. So, sit back, relax, and let's get into it. If you've heard of Ethereum, you know it's not just another cryptocurrency. At its core, Ethereum is a platform designed to support decentralized applications, or dApps. These applications can range from simple projects to incredibly complex systems. The beauty of Ethereum lies in its ability to quickly create secure applications that can interact efficiently with each other. How does it achieve this? Well, Ethereum combines a blockchain with a Turing-complete programming language. This allows developers to write smart contracts, which are self-executing contracts with the terms of the agreement directly written into code. This opens up endless possibilities for everything from basic ownership agreements to advanced financial contracts, and even voting systems and decentralized governance. Now, let's break down some of the building blocks of Ethereum to understand how it works. Ethereum's core structure revolves around two main types of accounts: externally owned accounts and contract accounts. Externally owned accounts are controlled by private keys, while contract accounts are governed by their own code. When someone sends Ether, Ethereum's native cryptocurrency, from one account to another, they're initiating a transaction. These transactions are like little messages that include the sender, the recipient, and the Ether being transferred. And the magic behind these transactions? It's all about gas. In Ethereum, gas is the computational fuel that powers these transactions. Every operation within the Ethereum network costs gas, and miners get paid in Ether for verifying these transactions and maintaining the network. Speaking of miners, how does Ethereum handle validation and ensure transactions are legitimate? Ethereum's blockchain is structured differently from Bitcoin. Instead of only storing transactions, it also keeps track of the current state of the blockchain in each block. This includes account balances, contract code, and other important details. It does this using a structure called a Merkle tree, which helps keep things efficient as the blockchain grows. When a transaction is processed, Ethereum verifies it using its state transition function. This checks all the details, ensuring the sender has enough Ether, validating all data, and even executing any code tied to a contract. If everything checks out, the transaction is confirmed and added to the blockchain. If anything goes wrong, it reverts, but the miner still gets paid. Let's shift gears and talk about smart contracts, the true innovation of Ethereum. These contracts run on the Ethereum virtual machine. The Ethereum virtual machine is Turing-complete, meaning it can execute any computation that can be described by a program. The big challenge is the risk of infinite loops, when code keeps running without stopping. To prevent this, Ethereum imposes limits on how much computation a contract can do, ensuring that every contract finishes in a timely manner. Beyond contracts, Ethereum supports a wide range of applications. There are three main types. 1. Financial applications. Think decentralized exchanges, currency swaps, and self-executing contracts for things like employment agreements or loan contracts. 2. Semi-financial applications. These combine elements of finance with other uses, such as bounty systems where people get paid for solving specific tasks. 3. Non-financial applications. These include online voting or decentralized governance where decisions are made by the community. One fascinating application is decentralized autonomous organizations. DAOs enable decentralized management of funds and decision-making without a central authority. Members can vote on proposals, manage assets, and adjust rules, all via code. Ethereum is evolving. The protocol is being updated to improve scalability and security. For example, with Ghost Protocol, Ethereum addresses issues of centralization in mining by considering stale blocks in the longest chain calculation. This helps ensure that the network remains decentralized while being secure. As we wrap up, one thing is clear: Ethereum is not just a cryptocurrency. It's a platform with endless possibilities for innovation, decentralization, and reshaping how we interact with data and value. Whether for financial applications, decentralized governance, or decentralized file storage, Ethereum has the potential to revolutionize entire industries. So that's a wrap for today's episode. I hope you now have a deeper understanding of Ethereum and why it's one of the most exciting projects in the crypto space. If you enjoyed this breakdown, make sure to hit that like button, subscribe, and drop any questions you might have in the comments below. Thanks for tuning in, and until next time, stay curious and keep exploring the world of crypto.